Every day, millions of people open a transportation app, tap a button, and watch a small car icon move toward their location. Within minutes, a driver arrives and the trip begins. What feels like a simple digital convenience is actually the result of one of the most complex real-time marketplaces ever built: Uber. On the surface, Uber looks like a ride-hailing service. A passenger requests a ride and a nearby driver accepts the trip. Payment happens automatically through the app. The process feels seamless, but the system behind that moment is far more complicated. Uber operates a two-sided marketplace, connecting riders and drivers. On one side of the platform are passengers looking for transportation. On the other side are drivers offering rides using their own vehicles. The platform's job is to match supply and demand in real time. This is not a simple scheduling problem. Transportation demand fluctuates constantly. Rush hour, weather changes, events, and city activity can dramatically shift how many people request rides. At the same time, driver availability changes as people log on and off the platform. To keep the system functioning, Uber relies on dynamic pricing. When demand increases in a particular area, prices rise temporarily. Higher prices encourage more drivers to move toward that location while also balancing rider demand. When supply and demand return to balance, prices fall again. This pricing system acts as a signal. Drivers see opportunities where demand is high. Riders see price changes that reflect current conditions in the transportation network. The platform continuously adjusts prices based on real-time market activity. But matching riders and drivers quickly requires enormous computing infrastructure. Every ride request triggers a series of calculations. The system identifies nearby drivers, estimates travel times, predicts traffic patterns, and calculates an expected fare. All of this happens within seconds. Behind the scenes, Uber relies on global cloud infrastructure processing millions of transactions simultaneously. Mapping systems play a central role in this process. The platform uses detailed geographic data to estimate travel routes, calculate pickup times, and predict trip durations. Algorithms analyze traffic patterns and historical trip data to improve accuracy. But the platform is not only about ride matching. Over time, Uber expanded into a broader mobility ecosystem. The app now connects users with food delivery services, package delivery options, and other transportation choices. Each service relies on the same core marketplace infrastructure. Drivers and couriers move through city networks, fulfilling different types of requests throughout the day. This expansion increases platform activity. More types of services mean more opportunities for drivers to find work and more reasons for customers to open the app. The platform becomes a central interface connecting urban logistics with digital demand. Yet operating a global mobility platform introduces challenges. Cities have different transportation regulations, infrastructure conditions, and traffic systems. Platforms must adapt operations to local environments while maintaining a consistent user experience. Competition also exists across many transportation options. Public transit, taxis, personal vehicles, and emerging mobility services all compete for urban transportation demand. Platforms must continuously improve efficiency and reliability to remain attractive to riders. Despite these challenges, the system continues to evolve. Artificial intelligence helps forecast demand patterns. Routing algorithms improve driver efficiency. Pricing systems adjust dynamically across neighborhoods and time periods. All of these layers operate simultaneously to coordinate millions of trips each day. From the outside, Uber appears to be a simple ride request app, but underneath sits a digital transportation marketplace. Algorithms matching riders with drivers in real time. Pricing signals balancing supply and demand, mapping systems guiding vehicles through city streets, and a global platform coordinating millions of independent participants. Transportation once depended primarily on physical infrastructure. Taxi fleets, bus routes, and train networks defined how people moved around cities. Uber introduced a different model, a digital marketplace capable of coordinating transportation dynamically across entire urban areas. And that system turned a smartphone app into one of the most influential mobility platforms in the modern economy.